Anti-inflammatory diets, often framed around clean eating principles, have become increasingly popular as a strategy to reduce chronic inflammation, support immune function, and improve overall health. These diets typically emphasize whole foods, vegetables, fruits, nuts, seeds, lean proteins, and healthy fats, while minimizing processed foods, added sugars, refined grains, and artificial additives. Scientific evidence consistently shows that such patterns can lower markers of inflammation, reduce oxidative stress, and support cardiovascular and metabolic health. However, emerging research highlights a less discussed aspect. When these diets are followed too rigidly or restrict entire food groups, they may unintentionally create gaps in critical micronutrients, potentially undermining metabolic function and long-term health. Understanding this balance provides insights into optimizing anti-inflammatory diets without compromising essential nutrient needs. Micronutrients play fundamental roles in regulating metabolism, energy production, and cellular function. Vitamins and minerals such as B12, iron, iodine, zinc, magnesium, and selenium are crucial for enzymatic reactions, hormonal signaling, and antioxidant defenses. Overly restrictive anti-inflammatory diets that eliminate animal products, dairy, or fortified grains can inadvertently reduce intake of these nutrients. For example, strict vegan versions of anti-inflammatory diets may provide ample vitamin C, polyphenol, and fiber but may fall short in B12, iron, and zinc, which are vital for red blood cell formation, thyroid function, and overall metabolic efficiency. Similarly, elimination of certain grains or legumes without careful replacement can reduce magnesium and folate intake, both of which are important for energy metabolism and DNA synthesis. These nutrient gaps, if unaddressed, can subtly impair metabolic pathways over time, even in the context of otherwise healthful eating. Another critical consideration is the interaction between diet quality and nutrient bioavailability. While plant-based foods are rich in antioxidants and anti-inflammatory compounds, some nutrients are more efficiently absorbed from animal or fortified sources. For instance, iron from plant sources, non-heme iron, is absorbed less efficiently than heme iron from animal products, and absorption can be influenced by compounds such as phytates in whole grains and legumes. Similarly, calcium from plant sources may be less bioavailable than from dairy, depending on oxalate and phytate content. Without strategic combinations, such as pairing iron-rich plant foods with vitamin C sources, micronutrient absorption may be compromised. Overly rigid, clean eating patterns that avoid these careful combinations can exacerbate deficiencies, highlighting the need for thoughtful diet planning. Despite these potential challenges, anti-inflammatory diets retain strong metabolic and systemic benefits. Diets emphasizing colorful vegetables, fruits, nuts, and omega-3 rich foods support healthy lipid profiles, improved insulin sensitivity, and reduced inflammatory markers such as C-reactive protein. Polyphenol and flavonoids found in berries, green tea, turmeric, and leafy greens enhance antioxidant defenses and modulate gene expression related to inflammation and metabolic regulation. Fiber-rich anti-inflammatory diets support gut microbiome diversity, promote satiety, and improve glucose regulation, demonstrating that the core principles of these diets provide substantial health benefits even when potential micronutrient gaps exist. The positive perspective is that anti-inflammatory diets are highly adaptable. By identifying potential gaps and incorporating targeted foods or supplements, individuals can maintain the anti-inflammatory advantages while meeting essential metabolic needs. For example, including fortified plant milks, nutritional yeast, seaweed, iodized salt, legumes, seeds, and a variety of nuts can help address B12, calcium, iodine, magnesium, and zinc requirements. Small adjustments, such as adding fermented foods for gut health or pairing iron-rich foods with vitamin C, can significantly enhance nutrient absorption and metabolic support. These strategies demonstrate that restrictive diets do not have to compromise nutrient adequacy. Rather, they offer opportunities for mindful customization that enhances both anti-inflammatory benefits and metabolic resilience. Another advantage of anti-inflammatory diets is the emphasis on whole, minimally processed foods, which generally contain fewer empty calories and less added sugar than typical Western dietary patterns. Even when micronutrient gaps exist, the overall reduction in processed foods supports stable glucose regulation, improved lipid profiles, and better cardiovascular health. These systemic improvements may partially compensate for modest nutrient deficiencies, illustrating the body's resilience when dietary patterns are generally nutrient-dense and anti-inflammatory. With careful planning, the same diet can provide both metabolic protection and reduced inflammatory stress. Long-term adherence to a thoughtfully structured anti-inflammatory diet can therefore offer a dual benefit, reducing chronic inflammation and supporting key metabolic functions. The emerging research emphasizes that potential micronutrient deficiencies are not inevitable but are highly dependent on food variety, supplementation where necessary, and careful dietary combinations. Rather than being a limitation, this knowledge empowers individuals to refine their eating patterns, ensuring that anti-inflammatory benefits are maximized while metabolic needs are fully supported. By combining whole foods, strategic nutrient choices, and awareness of absorption interactions, anti-inflammatory diets can function as a comprehensive approach to both chronic disease prevention and metabolic optimization. In summary, while popular anti-inflammatory and clean eating trends provide powerful systemic and cardiovascular benefits, overly restrictive approaches can unintentionally reduce intake of critical micronutrients, subtly affecting metabolic function. The key lies in thoughtful dietary planning, emphasizing diversity, including fortified or carefully selected foods, and ensuring adequate intake of essential vitamins and minerals. When executed with attention to nutrient balance, anti-inflammatory diets not only lower inflammation and oxidative stress, but also support optimal metabolic function, gut health, and long-term wellness. Far from being a drawback, this insight transforms the concept of clean eating into an adaptable and evidence-based strategy for holistic health, combining anti-inflammatory advantages with robust metabolic resilience.